Okay guys, in today's video we are going to find the Lewis structure of carbon tetrachloride. First step we got to do in finding the Lewis structure is to figure out how many electrons we're dealing with. So if we think about carbon, it's in group 14, so it's going to have 4 valence electrons. And what that means is, well, we got one of those, and we got 4 electrons contributed. So we got 4 electrons from carbon. And for chlorine, well, that's in group 17. We've got 4 chlorine atoms in my compound. And because we're in group 17, they've got 7 valence electrons. We're dealing with 7 electrons each for each chlorine, and 7 4s are 28. And if we total those up to find out how many electrons we're dealing with in total, it's going to give us 32 electrons. Next step, okay, that's the first step done. Next step, we've got to figure out which atom is going to be our central atom. To do this, we've got to look at the number of bonding electrons each one has. So carbon has 4 valence electrons. So if we draw the Lewis structure for a carbon atom, it has 4 bonding electrons. Whereas if we look at chlorine, because chlorine has 7 valence electrons, if we fill in the Lewis structure for a chlorine atom, then it's got 1, 2, 3, 4, 5, 6, 7 electrons, and therefore it's got, if we look at this, it's got 1, 2, 3 pairs of non-bonding electrons and just the 1 bonding electron. So what this means is that carbon is the central atom because it's got the most bonding electrons. Okay, so just giving ourselves a little bit more room just to finish off our working out for this one. So to finish this off, what we're going to do is we're going to write our carbon as our central atom. Okay, and we're going to place a bond between each carbon and each chlorine. I'm going to represent that bond with 2 dots. So we'll continue with our black dots for carbon. We've got 1, 2, 3, and 4 for carbon. We'll use our red dots for chlorine, and each pair of electrons here represents a single covalent bond between carbon and chlorine. Next up, we need to put in those lone pairs of electrons on each chlorine. So this chlorine has 1, 2, 3, 4, 5, 6 electrons plus the 2 that are shared in the bond. That gives it 8 electrons and completes the octet. And this one, 1, 2, 3, 4, 5, 6, and this one, 1, 2, 4, 5, 6, and this one, 1, 2, 3, 4, 5, 6. So now we need to think back to our first step where we figured out how many electrons we were dealing with, and figure out have we used up all those 32 electrons. So if I have a look, I've got 2, 4, 6 on this chlorine, and 2, 4, 6 here, and 2, 4, 6 here, and 2, 4, 6 here. So all those non-bonding electrons on each chlorine atom, well, there's 6 on each one, there's 4 of those, that gives me 24 in total, plus the 2, 4, 6, 8 that are bonding electrons shared between the carbon and the chlorine. And if you add 24 and 8, it gives you 32. So all our electrons are used. The octet is complete on the central atom and all of the outside atoms. So that is my Lewis structure for carbon tetrachloride. Okay guys, thanks for watching. I'll see you again soon with some more videos from Mr. B.